All right, so welcome everyone to this last workshop of the robotics second cohort for this semester. Thank you guys for attending, particularly in these finals weeks. So thank you for making the effort. I really appreciate it. So first, I want to make sure that I checked in everyone. You just came. So did you register? Yeah. Okay. What's your name? Monisha. Let me look it up. Monisha, you said? Okay, great. Thank you. So today, as you can see in the title, so first, before doing the final project, so we're going to finish explaining some foundational concepts that we did, like as we did in the previous workshop with the digital pins. Now we're going to start using analog signals as well, which is the second part or the final part to round up the foundations for the Arduino concepts. And finally, in the last hour or hour and a half, we're going to build an AI Tic Tac game using the Minimax algorithm. So I hope that's going to be fun. And so let's jump into it. So as I said, so first we're going to start with the analog input for today's agenda. We're going to start doing some mini projects, which Nicole, I hope she comes soon with the kids. But in the meantime, I'll start explaining the concepts. And then finally, as I just said, we're going to build a tic-tac-toe game, and it's going to be against human versus AI. So regarding analog input, so the same way we saw in the previous workshops with digital pins and digital signals. So in this case, it's not going to be binary signaling. It's not going to be only zeros or ones. So in this case, we're going to be able to read anything between 0 and 1023 inclusive within that range. And if you translate that into electricity, because you get those values in the Arduino IDE, in electricity you get anything between 0 volts and 5 volts. So you're going to see in the future mini project we're going to do that we're going to change the brightness of the LEDs. So it's not going to be either fully turned on or fully turned off, but instead we're going to be able to manage the brightness gradually. And looking at the Arduino board, so we have, in contrast to the digital pins that was from 2 to 13 inclusive, now we have the analog in part, which has a red square. We can connect it to any pin between A0 to A5 inclusive. And again, those are going to be only for input. If you want to handle output, in the case of, as we did in the previous one, with continuous range, we're going to be using PWM, which is a special case for digital signaling. I think I made a mistake. Actually, it's not for output. We're not going to be doing it with LEDs, but you're going to be using it as input with the analog, anything between 0 and 1023. So let me see if we're going to wait for Nicole to bring the kids soon, but I want you guys to start looking at the diagram. So for those that weren't here, so we have in one side the Arduino board. That's going to be the brain of our robots, and it's the microcontroller that we're going to be using. We're going to be using, in this case, an LED. We're going to be using a 22K ohms resistor. We're going to be using one LED, and that little tiny component that you see there is our analog component, which is going to serve us to read analog input. And it's like a spinning thing that you can adjust. You're going to see that we're going to do it so we can adjust the brightness. And you need to make sure that all the time you use the specific resistor for the LEDs. And again, remember that, as we saw in the previous workshops, the larger leg of the LED is going to be connected to the positive side, or let's say in this case our digital pin, and also connected to our resistor, and on the other side is going to be our negative energy or our ground pin. So I don't know if, actually I need to wait for it's kind of delayed, the kits, but it should arrive soon. Let me see if we can do anything in the meantime. So any questions up to now that you want to, okay, yeah. The page. So you should go to, let me show you. So FIU.edu slash, let me actually remember because I slash explore hub. I think, yeah, go.fiu.edu slash explore hub, yeah. So we're going to be using, for those that didn't come to the previous workshops, we're going to be using this site, which is called the Notion page. And you should go here to this link, which is go.fiu.edu slash explore hub. Slash explore hub. And you should click on workshop contents for spring. Let me know if you found the page. It's not possible, but like, did you type go.fiu? Hardware cohort, yeah, cohort 2, and you should see a link to the Notion docs, exactly.
Robotics 101?
No, explore hardware, build an AI tic-tac-toe game. So if you click that one, it should take you to the Notion page, which you're gonna have the material that we're gonna use, and also we're gonna be using. So here I'm gonna upload all the files that we're gonna need for the projects, including the mini projects and the final one. Actually, I'm gonna change something. So. It should refresh. Yeah. I think they're probably going to need more LEDs for the tic-tac-toe. So we might.
Did I bring more kids?
Yeah. Oh, you grab. How many kids do you have?
I didn't grab a crazy lot. I didn't know how many.
We might. Maybe we can, like, I think, because they have like 8 or 7, so it should be 1 or 2 more for each.
I think I just need. Either way, I want to grab more, so I have them sharing. And I gave you guys one.
Do I have to connect to my computer?
Yeah. You have, what is that, Mac? That's Mac? Okay, so do you have a USB-C converter?
Yeah, I do.
Oh, okay, great.
The thing that I want to do though is I'll go grab that, but then I want to do the exit survey so that I have time to.
Okay, when?
Probably once I bring in that last one, because I need to then go through all the check-ins from all the workshops and do the calculations. So did you check everyone out?
Not, I think almost most. Yeah, I think most of them. I think one of them.
Okay, don't worry. I'll go
Yeah.
through and double check. So let me
Okay.
just go.
So I'll go on with the.
Yeah.
Okay, let me know if.
How many more kids should I get? How many extra LEDs?
No, like 4 or 5, just in case. Okay, so everyone has their own kits?
Yeah.
Okay, great. So we're going to start with the first mini project. If you guys can start wiring the same as you see here. So again, you're going to need the potentiometer. Great, thank you. You're going to need the potentiometer, that little tiny element that you're going to spin it. The LED, remember, the larger leg is the positive side, should be connected to the first to the resistor, and then the other pole of the resistor should be connected to the digital pin. And make sure you connect to the same pin, right? Because if not, the code is not going to work. We're gonna be doing the first project just to get started with the analog input, and then we actually gonna do it, use that information to change the brightness of the LED.
This is the board, right? The correct one?
That's the board, yeah, exactly.
Is this the one too?
Yep,
Okay, thank you.
you're welcome. If you guys have any questions, please let me know.
What's the potentiometer?
Let me help you. It's a little spinning.
This? No.
No. It's a little one, so. Let me see. Yeah. That one.
This?
Yeah. Did you guys could find the potentiometer?
Yes.
It's a tiny one, maybe. Okay. Let me help you.
This is the first workshop.
Okay, don't worry.
Yeah, we
I got you. Okay, nothing. Zero. Okay, so from scratch. So that's gonna be our Arduino, right? Yeah. So first, try to mimic whatever you see here.
Yeah.
The diagram. This is our electronics diagram. Make sure that it matches. Like the numbers are very important
Yeah, I'm trying to see.
because then when we code it, we're gonna be
It's going to be
specifying.
according to the
Yeah.
numbers. Okay.
With these?
Yes, those are the jumper wires.
So if you want, we can give them two as well.
Okay.
And then you have 3 for the extra LEDs.
Okay.
Or
Great.
you can
No,
have
no.
them share and then you have 4 extra.
Sure. Yeah. No. Yeah. I think it should be enough, right?
Whatever you want. I think they're fine sharing. I'm gonna leave these.
The question are these people who are surrounding us, they're mechanical engineers?
They are from everywhere. Yeah.
Everywhere.
Yeah. Mainly CS, but we have mechanicals. Yeah. There they have electricals.
Yeah, it would have helped if we had a course on this because,
Your CS?
yes.
Me too. Yeah, we don't have it.
Yeah, exactly.
Yeah. So that's why we have it here.
Yeah.
No, yeah, but it should be good at course, like for the program.
Yeah, definitely.
Yeah. At least basics electronics or basic Arduino. Yeah.
I guess that would be covered under what is it? Computer engineering, not computer science.
Yeah.
Computer science is like purely.
Pure software. Yeah. Let me know if you need help.
Okay.
Okay.
Thank you.
Has everyone been checked in? Is there anyone who hasn't been checked in? Yeah, because we have.
Yeah. Yeah, you need help?
Potentiometer to
Yeah, so it might not fit as it comes, like by default. So you might like shrink it a little bit, the legs or something. Move it so they fits one side of the breadboard.
Okay. And it's supposed to be like how it's here, right? So
Yeah. Exactly like that. Because that barrier you see in the middle is literally an energy barrier. So if you put one leg on the opposite side,
is it gonna short circuit?
yeah, it's not gonna work. Basically.
Yeah, so like that.
No, see that you have a one leg that is in the middle,
Yeah.
literally in the barrier. So you might move it that one a little bit like
Down.
to the inside. Yeah. Great. Okay. Do you want to do it like at the end? Or before the final project, you want?
I'd rather not do it at the very end, just in case people have to leave.
Okay.
But if we can do it whenever there's like a natural pause, whenever like you're moving from one to another, whenever maybe when they're done with this one.
Okay. Okay.
Because the thing is, once we give out the survey, then it'll take me like another like 10, 15 minutes to cross-reference
Ah, okay.
everything. So I'd rather not do it like.
No. Okay. So if you want, you can do it after the project 2, which is the next one. Before like the final project, the explanation and like the concepts.
But I think it's better to do it after this one, because then after project 2 we can stop and give out the pins, and then Sam is supposed to come with the pins.
Makes sense. He's supposed to. Hi.
We're supposed to like thread the ohms resistor like underneath it.
What do you mean? Like, yeah, should be. So you might like move it like a U shape. Yeah. So make sure it touches the bottom.
Just like this? Yeah.
Yeah, I don't think the potentiometer needs the resistor. That's only for the LED. Remember that the energy flows column-wise.
Okay.
So everything you put in the same column is gonna be fed with the same energy. So make sure you don't put it like the potentiometer and then the resistor and then the LED all in the same column. So, for example, this black one is feeding this column, the yellow one this column, the red one, and so forth. So. All good here? Any help? No? Okay. All good here, guys?
Yeah, I think
Oh, yeah.
a little bit.
Okay. Let me know. Here,
Should be good. I'm just trying to reconstruct it from last time.
make sure you put, like, because I see you're using 2 different sides
Oh,
for the potentiometer.
2 different ones?
Like sides, because here, remember, this barrier is literally an energy barrier, right?
Right.
So remember that if you put here something, it's not gonna feed the entire thing. It's gonna feed like up to here,
Okay.
like only this part.
So.
So, for example, you have here 2 legs on one side and 1 leg on the other side.
Yeah.
So make sure that the one that is feeding this is here, and the other 2 are here.
Okay.
That should work.
Okay.
But it's gonna be different from what you see in the diagram.
Got it.
Okay. Go for it. They have
I brought you one.
okay. Okay, no? Bye. Guys, for those that weren't here in the previous workshops, make sure that you download Arduino IDE, because then we're going to be coding there. So this link is in the Notion page as well. So while you do the wiring, please download it. Because we got new people.
Yeah, that's fine. I'll just make sure that they have what they need.
Yeah. Please help. Okay.
Oh, is this a joystick?
Yep.
Is this
No, that's another thing. But it's a tiny thing that is like you can spin it. No, it should be like free somewhere.
Oh, is it this? Oh no. It's
No,
not this.
no.
No. See if you can
It looks like it's a thin. Oh, I think it's actually that one. Look.
this. Oh,
This.
I see it.
Yeah, that one. Exactly. Yep.
In the diagram, this should go to negative or ground?
Which one, sorry? The. Okay, that should be. So.
Here?
Yeah,
right
the
one.
positive. The positive.
The positive or the negative? It looks like the negative.
No, because that's turned the other way around.
Oh,
Yeah, don't worry, and I think it's actually bipolar, so you don't have to worry.
okay.
Yeah,
But wait, one of them is connected to the 5 volt.
the 5 volt.
But this one is.
So the other one should be the ground.
Right, so negative.
Okay, so I didn't know you were using, yeah. So negative, yeah. So because the convention for the wires for the future, so the black wires, you generally use it for the ground.
Yeah.
And maybe colorful wires for the positive or other stuff.
okay.
So it's better to switch it. Yeah, I think it's better.
I just want to know if we're doing, well, we have all the connections right on the breadboard.
Yeah, let me see.
You try to follow these pictures really
I think it's,
closely, although it's just because they don't have numbers and the letters on the side.
yeah, I know. So always you need to make sure, because I see probably there's a mismatch, but you just need to move it to the left, the potentiometer. Because remember that for the breadboard, the way that the energy flows is column-wise. So for example, if you connect this red wire, it's going to fit only this column, right?
Yes.
Or the leg, which is the pins. So I think here, for example, it's not hitting the pin.
The black one?
All of them, actually.
Oh.
No, I mean, not that one. These three.
This?
Yeah, so you might just move it one column to the left.
Okay, so,
Yeah,
Oh,
I
I
know.
know you
I
mean
know
that.
it's microscopic, but
yeah.
no, wait.
No, it's put this like behind them.
Because you need to expose them to the electricity in the column,
So,
remember?
right here,
Yeah,
right?
exactly.
Oh, okay.
Yep,
Okay, thank
great.
you.
Let me see the LED just to make sure.
Or do you have to
So-
flip it? Because I know one
I think...
thing has a small.
Yeah, so I see
legs?
first. So same. For example, here the resistor is in this column. And this leg of the LED is on the column of the left, you know?
So we have this leg has been the same column as
Yeah,
the LED?
it should be the same column. So the energy flows column-wise.
Okay, now it's in the same column.
Exactly.
Oh. Okay.
Make sure did you pick the right resistor, like the 220?
Oh, the options.
Because there are many different
Was there?
resistors.
Is it? This is it? Or
No. You might have.
unless I wanted to hook to the thing.
Oh, you don't have the. No, actually, let me grab resistors for you.
Oh, thank you.
1 sec.
Here, you want to grab some mine?
Oh, okay. Thank you, man.
Just easier.
Yeah, thank you.
Oh, these, the yellow.
Like, no.
No.
These?
Oh, yes. It was hidden. Thank you. So you see there are different like numbers. They're labeled.
Oh, yeah.
So you have 10K, 100K, 1K. We need only 220 for the LED because they don't require too much energy.
This is 220. This is 220. So
Yeah, 220, yeah.
this one's
Yeah, those restrict like the energy flow. So
And
you don't burn the components, and
okay.
they're very important, yeah.
So this changed this one.
Yep.
Okay. So
Part is the
Wait, let me go that side.
this? I've tried finding something similar to that, but this is the only thing that is.
Yeah. So
It is this
no, set that apart because we're gonna use it next. But for now, it's
one? Okay.
a little. I know it's so.
It's in this?
It's not here. No, not here.
First, generic paragraph
It might be free somewhere.
Oh wait, is it one of these?
No.
Oh.
You might not have it though. I might grab one for you. I think you don't have it. No, yeah. Let me grab one for you. Look, this one. You didn't have it, I think. So you see, you can spin it. You don't. Oh, you guys have two. My bad, my bad. So two are missing?
What am I missing in the kit?
No, one component, the potentiometer. Potentiometer. So let me see this here. So one for you here. You're welcome. So you could wire it? Yeah, I see.
It's all wired. Just gotta put the,
Great. So here is set up already? Okay, great. Here, all good?
Yeah.
Wait, so after we do
Do you
this,
join Arduino IDE?
Arduino IDE, did you download it?
Oh yeah.
now where's it at? Where do we download it at? Oh,
So you can visit the Notion page or I just can tell you.
yeah, I see it. This is it, right?
Yeah, exactly, that one.
Thank you.
You're welcome. Guys, do you have the Arduino IDE download?
Yeah, I was about to.
Yeah, okay. Oh, so you can go to a Notion page or I just can tell you where you can find it. So you just Google it, it's literally.
Wait, oh, no, it's not
So,
on this.
yeah, so go below.
Oh, below.
Yeah, so hardware, Notion, that one, the last one.
Okay, yeah. This one?
Yep.
Okay.
So intro materials,
What intro materials?
yeah, installing Arduino IDE.
Oh, okay.
There you go. So the link should be there. Exactly.
Oh, also quick question. This one, it's not connecting as, you know,
So yeah, you might, so
you have to change the
you might like shrink the legs a little bit or move it so that it can fit.
fit in into the.
Yeah, or what you can do, because how the energy flows here, like in the breadboard, the little white thing,
Yeah.
there's a breadboard. So the energy flows column-wise.
Okay.
So for example, here you connect this black wire, so it's gonna feed this only this column up to here.
Okay.
This is an energy barrier.
Okay.
So if you connect one side to this side and then one leg to this side,
Yeah.
make sure that the
The one leg.
those that are exposed to these pins are like in the same side. You know what I mean? Like,
I think.
so for example, let's say we put it because let me see. Say we connect it like this, right? Oh my gosh. Technical problems. Let's see.
Yeah.
So we put it like
Okay.
there you
And
go.
the-
So,
oh, so the-
you see it's in the
the-
middle. Yeah. So
that pin should go to the other side.
the other side.
Oh, okay. Okay.
Exactly.
That was the question.
Yeah. Which you can do it actually. So
I think it's good, right?
let me see. It looks good. So just to make sure the LED, the larger leg is exposed to the resistor because that's the positive side of the LED.
Oh, the larger side?
Yeah, like it has a larger. Yeah. So
It's in this direction.
oh, so it should be
Oh, like
the
this?
other way around. Yeah. You just need to flip it. Exactly. All right, looks good. So, did everyone get their diagram set up already? Yes? Like the wiring part? Yeah, okay, great. So we're gonna move on with the code. So if you guys downloaded the Arduino IDE, please open it. So we're gonna start uploading our first Arduino sketch for today's workshop. So we're gonna be doing for this part is only debugging it and see what values do we get if from the potentiometer, which just to make sure that everything is working before using it for something else. So you just need to type this code, and if everything is good, it should work and show in the serial monitor, which after you type it, I can show you how to open it. You should see the output, which the serial monitor, by the way, for those that weren't here, is like the terminal, the programming terminal.
So we just copy paste that poster?
Yeah, just to see if everything is working. No, this one you need to type it manually. It's on purpose so you get used to the syntax.
Is this Raspberry Pi?
No, Arduino, C++. What's up, man? Did you register for today's?
Yeah, I did.
Yeah? Okay, let me check you in. What was your name again?
Adrian.
Adrian. Great, thank you. Let me give you one kit.
Thank you.
So if you go to the Notion page, you will find the diagram for this one.
Are you computer science, bro?
Me? Yeah, I'm computer science. What about you? Me too. After what? Finish? So, yeah. Let me show you, actually. Yeah, so, okay, so it's this code, right? Yeah, okay. So I'm gonna explain it first. So I'm gonna make a quick recap about the structure of how we're supposed to like structure the Arduino IDE sketch. So at the top of the file, so we should include all the variables that we're gonna be using, which are gonna be both. First, the ones that are gonna change, and then we're gonna define our constant values. So for the constant variables, you're gonna see that most of the time, and you're gonna see very common, we define the pins that we're gonna be using. The pins are basically those little tiny black holes in the Arduino board. So you need to make sure that when you connect any component to the electronic board, it matches what you have in the code. So for example, in the case of the LED, make sure that it's on pin 9, or if it's not, you can either change in the software side or in the electronics part. It's easier if you do it in the software side, so you don't need to manipulate all the components again. So, and then, for example, here we define LED to pin number 9, and then the potentiometer, the pin is going to be A0, which is basically it's a variable that Arduino already provided for us. It's not any native type from C++, right? So, and the same thing for the variables that will change. In this case, we're going to be using or declaring potentiometer power and also the scale value. So we just define in that step because those variables are going to take some values during the program. So then the second part of the structure, so first the variables. Then we have the void setup here. So in the void setup is basically the first thing that runs in a robot. So everything that we need to set up a robot, everything is going to be in that function, including first we're going to be using the pin mode, which is really, really important. So we are telling basically Arduino, so we're going to be using the first parameter is going to be the pin number. And then as a second parameter, we're just going to tell Arduino if that pin is going to be using an input or output component. That's for the pin mode. So everything should be explicitly like specified in this part. And for example, here I put a comment that for analog input in this case is not required, so Arduino will identify it by itself. But for the LEDs and the digital pins, you do need it. So, and also a very important step. So to use it's not the terminal in Arduino environments because we're using electronics board. But we are using a serial communication protocol, so you just say it by typing serial.begin, and the argument is the baud rate, which is, let's say, a frequency that Arduino will listen to the port. So then, and the most important one, I would say, is where the logic comes, which is in the void loop. So you see that in the line 23, we set the potentiometer power to whatever is the output of the analog grid. So the analog grid, again, we go to the PowerPoint. So here the analog grid is the function that Arduino provides for us for analog input. So remember that all the values that we're going to get, if everything is working, should be anything between 0 and 1023 inclusive. So in that way, so for example, if we read if we get as an output, if we call that function and we get 0, it means that, for example, the potentiometer is spin all the way to the left, like the minimum power, and the same way the opposite side, it should be 1023. So in this case, potentiometer power is going to take anything that is the current state of the electronics component, right, in real life. And then what we do here, which is very important for the next project, so the second most important function or the built-in function that we're going to be using is the map function. And the first argument, if we see the PowerPoint here, the first argument from the map function is going to be the value that we want to convert. So it's basically we know that for sure that their input is going to be anything between 0 and 1023. But from the previous workshop, remember if you were here, we're gonna be using PWM, which is digital output, a special case for digital output, which is going to be anything between 0 to 255. So basically what we want to do with the map function is to convert whatever input we have from the component, and then translate that that range from 0 to 1023 to 0 and 255. So that's going to be very important to then, for example, change the brightness of the LED. So so how do you upload the sketch to the Arduino? So you need to click this arrow button pointing to the right. Yeah.
How is the LED pen supposed to get the value?
So you mean what values you should get?
Yeah, I mean, I see the print statements, it's working, but the light's not turning on.
No, because here we don't have yet we are not using the light yet. It's just the setup for the next one. So it's just to debug if the potentiometer is working. So if you click this arrow button, then you should upload it, and then it should work right away. And how to see the output if it's working, you should go to the serial monitor, which is just by clicking this little icon. So you're going to see like a terminal here, and then whatever value is being printed. So try to play with the component and see if the values change. Let me know if it's working. If not, we need to check on it. It's working?
Yeah, I have a question just for the Arduino.
Yeah.
When it stopped flashing, the color is this green and two yellow lights. That means the
Let me see.
okay.
Let me see.
Connected it to the computer.
Let me
I
see.
don't know what this indicates. The green.
So the green one, okay, so let me see. I think the green one is just to say, okay, it's power on.
Okay.
Then the other orange one is like some code,
Okay.
like light code that I probably don't know, but it should be working.
So it's compiled.
It's compiled,
Yeah,
so
press
you
the
compile
arrow,
it,
and
and then the arrow you uploaded it,
I compiled it, yes.
and then uploading it. So you see, whenever you upload it, it's like blinking a lot of times.
Yeah. So after that, what do we do next?
So now you should go to serial monitor, which is that one,
Mhm.
and then it should be endless. There you go.
Oh, okay.
So try to spin it, see if it changes the values.
Spin what?
Like the,
This, right?
yep. It's like volume. Let's say it's like, take it as volume.
What is it doing?
Yeah, what is it doing?
It's changing the values. So
Oh.
it's to get more power or less power.
Oh,
let me
yeah,
record.
yeah, same thing.
You see? So the maximum you see is 1,000 and almost 23, and the minimum should be 0.
Yeah, this is, yeah, you see the zero.
There you go. And the scale value, we're going to be using that value to feed the LED,
Okay.
basically. Did it work, guys? For everyone? Is it working? So we move on to the next one. Wait, can't hear you very well.
I didn't complete writing the code because I was installing everything.
Let me put it for you.
Let me know.
No, yeah. We finish this and then. What? Oh, yeah. Thank you. Is it working? Yeah. So you try playing with the component, like spinning it, to see if it changes the values. There you go. Are you spinning it? If it's not changing, it might have some issues.
Give it a sec. We're gonna give it out once we give out the prize.
I think, is it working? It looks like, yeah, you see, like sometimes it's like some weird behavior because probably it's electronic stuff, or probably the component is not really good quality. Yeah, I think it's working. Yeah, awesome.
How are you, bro?
Good.
Just wanted
Okay.
to show some support.
Ah, yeah, thank you, man.
It's your last one, right?
Huh?
Last one, right?
Yeah.
Feels good.
What did you say?
This is the last one, right?
The last one? Yeah, my last one. Yeah. Yeah, it's good. But it's finals week though.
I
He
know.
just said, "Sí, se conectó." Like he did not hear what
No, no, no. It's
I do the same thing. Seriously.
you do.
I do the same thing.
Thank you for not making me feel bad.
I hate asking people out of there. I'm like,
No, I will never.
No, but I hear bad. Like, what did you say? My bad, my bad. Yep.
So should it only change value if I'm moving it around, or should it change value even if I'm not touching it?
So yeah, you see, like it's sometimes like it's not very stable, right? So it's not up to you. It's like not your fault basically, because it's some behavior from the component which is normal.
So it,
But as long as it's not like 350 to 700, it's fine. But it could be anything between 340 and 360, let's say.
okay,
Yeah.
thank you.
You're welcome.
Caesar,
Yep.
where's the potentiometer?
So it's a little okay. So I see. You got the half the potential. So it should be a 3-leg thing. I don't know why it's like separated. It was like that before.
Yeah.
Crazy. So set this apart. So we're gonna be using that? No, afterwards, but we can set it apart. So let's see. No. Using the.
Is it in this one?
You know, let me just grab you one new one. Let me see.
Whoever was last using this.
Yeah.
The other half.
No way, the same thing? Oh, here. Look. Oh my gosh. This one.
Oh, okay.
There you go.
Thank you.
Do you want to. Wait, let me put it here. If you want, you can do it. Yeah.
Put up my little thing.
Yep. In the meantime, they finish with this.
Should be pretty quick because there's not a lot of people.
So it's your Notion page, right?
Yeah.
The one that you sent me? Okay.
Yeah.
I closed it.
But if you want to just go into the Notion,
In the Notion.
go to Explore, and then go look up program. Okay. Chill. All right.
Your turn.
Yeah, I guess I don't have to do most of it because they already have the Explorer. Okay, hi guys. Really quick, we're gonna do the exit survey. I'm gonna give you guys small spiel that I usually do, although since this is the last workshop for the semester for Explore, I'm not gonna say too much. The first thing I want to highlight, is this exit survey. Please take a second to fill this out. It's really important for us to get feedback from you guys to make sure that the program is working for you, make sure that we make any improvements in the future, And most importantly, if you guys have attended all 3 of the workshops for hardware, not including that intro one, then you will not get your pins unless you fill out this survey. So please take a second to do that now. Even if you filled it out for another track, it's always helpful to get more specific feedback on, the individual track that you're actually participating in. So if you can take a second to do that, that'd be awesome. And then in the meantime, I'm going to talk about the fall. Fall is going to look pretty similar. We're going to have our 4 tracks. We have our web dev, game dev, AI, and hardware. We have this cohort style where you take 4 weeks and you build out your projects like you've been doing. It's going to be a little bit different because we do have shell hacks. So I encourage you guys to stay tuned and, keep kind of dipping your toes into all these different fields that you like.
Anything else?
After we finish typing out the code, do we just
Okay. Okay, so yeah. So you tried uploading it, it's working?
Oh, wait, I haven't tried uploading it.
You didn't try? So whenever you have the code, so click this arrow button to upload it. So you should see in your Arduino, when you upload it, it's like quickly blinking all the built-in LEDs. Let me know. Did you upload it? Yep. You're not getting values? Like analog read, scale value? No, don't worry. Actually, so wait. So open the Arduino, IDE.
Where is that?
Like,
Here?
oh wait, where are you? What? Wait, what is that? Oh, no. It's like, oh no, it's minimized. I didn't understand like what's going on. No, don't worry. Okay, so did you upload it?
Yeah.
Okay, so click serial monitor,
This?
that one. So in that way, it's like the terminal,
Oh.
And here you get the out, there you go. So try spinning it and values should change.
Oh, okay.
So now we're gonna be using the scale value because we don't need this value anymore. We need the scale value to power on the LED, which we're gonna do now.
Oh, okay, got it. Thank you.
You're welcome.
I got
Did you get it?
I'm not following along.
Oh, okay. But if you have any questions, ask me. Oh, what happened? Oh, really? Oh, no. Oh, if you want to pair up or something?
Recording. I'm following.
Okay. But if you want, you can pair up or with someone.
papi, ¿todo bien? Estoy en una cosa de programación ahora.
Println.
Algo de robótica.
Hello. Okay, guys, so is that running? Yeah? Okay. So we're going to use now, for which you're actually going to do it, which I'm going to give 10 minutes because I want to do the final project. I think that's the best one. This project. Okay, so now I'm going to upload in the Notion page. I'm going to upload the backbone for basically this file. So in this case, you can use whatever we just used with the map value and the analog read. So you can use that information to do this. And then you already have your LED connected. So you just need to use, in this case, digital write to pass energy to the LEDs. So you're going to use that value. Let me show you, for example.
I put println in the message in the serial monitor.
Yeah.
Is it supposed to do something after or just?
Println is like instead of println.
Okay, just println.
Println, yeah, just for one of them. So it breaks just one line. I'm going to upload the file. So let me CPT, no. workshop 2. So if you go to project 2 in the Notion page, you're going to see now the file that you might use. Not this one. Project 2. So now it should be live with the project. You ready again? All yours.
Let's do it so we can give out
I see.
if it doesn't sound like a time.
No, don't worry. Of course.
Why would I?
I assume it.
That's a good joke.
Let me finish this one, and if you want, we can do it. Nico, do you want me to finish this one? We do it together, and then before the final one.
My biggest concern is the pizza getting cold.
Oh yeah. Okay, pizzas and Arduinos are not very good, combination. Yeah.
So do you like doing robotics? You guys like doing robotics? It's like they both like being a computer science student.
Say that again. Sorry.
You know how like people like in computer science have like their niche where they want to focus on like AI.
In robotics, yeah. So for machine learning, exploration.
Is that what you guys are interested in doing?
Yeah, actually.
I also work. We both work at research labs that focus on like uses of robotics, but
Yeah.
some can be more like from the software side, some can be more from the hardware side. So
Exactly.
it depends on what you're interested in. Like if you really like the hands-on part, you go more into the engineering robotics side. If you like more the theoretical side, you can still work in the software and the autonomy.
Yeah.
You like it still into the robot.
For hardware, do you have to be? Do you need to be like an engineering student, or just like?
I think the engineering program gives you good foundations that you should have. That being said,
Thank you.
oh, if you're gonna go, you can take a slice of We're a little concerned though because of the Arduinos. Like you need to be really careful. I don't know. Yeah, we don't know if you guys should be eating while working with them.
Guys,
Figure it out at the end.
any volunteer for this solution? We can do it together. So we jump to the final project.
You're trying to.
The first to do. I just type whatever you say.
The potentially, so analog read, that's like user input.
Yeah.
Then you would get you would pass in the potential, the power variable that you declared earlier in global, and decide the parameter, and then I pass it back again into like the variable.
So like this
Analog read.
equals analog read. Something else? then scale value equals map.
Parentheses, potentiometer power.
Exactly. First argument, second argument actually.
0.
0,
1023.
1023,
0 again.
0 again,
255.
255. And for the last one, to turn on the LED,
Here's that. Serial print analog print. Serial print with parentheses, double quotes, analog read. Serial print analog data.
okay, yeah, that's for debugging. But to turn on the LED, what function do we use? Turn that on. Similar. So we should use analog write, but how? Why for loop? Yeah, that's if you want to do it like dynamically with programming, but we are doing dynamically with the component. So it should do, because remember that, so this is PWU signals. So why we are scaling the value? Because PWU signals for output components read anything between 0 and 255. So if we pass 1023, like raw value, then it's not gonna work. So we need to scale the value first, and then we say what is the first argument here for the analog write? LED pin. And second argument, scale value. Okay, try this and it should work. The other one. That one. Yeah.
And after that, we do like loosen the arrow. Just click on the arrow on the top left.
Yeah, again. So you need to upload the code again, guys. Yep.
So I'm not sure. I mean, the code the correct way. I think it's something with the. Is this correct? Like.
No.
No.
Oh, let me see. Oh, A0 ground. Using ground. So wait. Ground. That's fine. Oh, actually,
So it has something to
it's
do with
working.
this? Oh, does it work?
Oh no, but it's not changing.
Yeah,
Oh,
that's what I mean.
but maybe maybe it's not really well connected. There you go. Did you try to debug it?
Hold on.
Like to see the analog values?
Oh wait.
Oh wait, let me see, because maybe you're missing. Oh, you know why? Because you're putting one penalty
Oh.
here in the other side.
So after we send
that makes sense.
send the code in, it's supposed to turn on, right? The LED.
The upload, yeah.
Shit, it's not.
It's not.
Do I have to bend this a little bit? So that
Yeah. Or you can just put this blue one in the other side.
Oh, okay. Then I'll just
Exactly.
do this and then the blue one
In the middle.
right
In
here.
between. Yeah, exactly. Make sure it's in the middle.
Okay, hold on.
Okay. Spin it. Did you check what values is passing? Like the serial monitor? Open the serial monitor.
Oh, that's here.
So, oh wait, you need to do, so you can do serial.println. So that's a good way of debugging, to see if the electronics is bad or the software.
Serial.
dot println and just put the scale value.
Okay. Yeah.
So it's not shifting, right? It's not changing.
It's just staying at 255. So it's got to be something. Like
Something
that.
from electronics, yeah. Let me see.
In the serial monitor, you put serial println if you want to debug, right?
Yeah. Serial.println. So, wait. So 5 volt. So the red one is 5 volt, right?
Yeah, red is on 5 volts here.
Yeah.
This is on ground.
Uh-huh.
Wait, is it on ground?
Oh, no, it's not.
It's not here. That may have been why. Let's see.
Let's see now. Oh, there you go. But it's not turning on the LED. So now you have
So now I have an LED.
the LED.
Now I have an LED.
You have the LED.
Let's see. Okay, so
It's working? That's talent.
Can I?
Huh? Yeah, you told me.
I was working on this last time.
Yeah, I remember. You stayed. What happened? It's not working. I mean, the potentiometer is good, but
that's
the LED, which is should be the. Wait, why do you have? So, it's been 9.
yeah, it's on 9. LED pin
It's
is
on 9.
And then-
So it's the positive. Did you check
oh
that?
wait,
Oh no.
I'm on the other way around. That's why.
I'm gonna get electrocuted. Let's see now.
All right,
It's not working, I think.
still not working. Let's see.
So, wait, the resistor is fine.
The
Is
resistor-
it 220? Oh no, you get one of this?
Yeah.
No, that's why it's not working.
Oh.
So it's
Which
too
one of
much restriction. 220.
Oh, is it 220? Oh.
220, yeah.
Wait, bro, is it?
Is it turning on?
No, it's not.
It's not. So the values are good.
Yeah, I'm passing in the potential power 0, 1, 10, 23, 0, 2, 2, 5.
And when you debug it with the serial, it's changing when you spin it or not?
I can't really tell the difference.
What do you mean? You should
It's serial
tell the difference.
dot.
No, wait. Oh, wait. Try doing. So do here println in this one and in the third one.
Yeah, third one too.
Third one, yeah.
So okay, like that.
Yeah.
Okay, then I just.
So actually, the first one and the third one, yeah.
First one and third one. Okay.
Here is working.
Should it be outputting anything?
It should be outputting the LED power, yeah. So it should change the.
Okay, turn on.
Serial monitor? Check the serial monitor. 1 sec. So it's, oh no, because we don't have, oh, you didn't write the code for the debugging. So try to spin it and see if it turns on. No. So type serial with capital S in the code.
In the code?
So we debug the scale value, yes, to see if it's something from electronics or serial.println scale value. That's very important to debug. Semicolon. Upload it. What were you saying? So now we have, okay, 255, 250. Okay. So try to move it.
The board?
Try to spin it. Are you spinning it? Yeah, right.
Yeah,
So something is wrong with the with the circuit, probably.
Do we have the numbers? It's just not turning on.
The numbers seem fine. Try to spin it a little more, like to the other side. It's kind of unstable. No, I think there is something wrong with the circuit. Yellow. The ground. It's 5 volt, right? That one? Let me see. I think maybe because it's not. Now it's rating fine, I think. Not too much. $250, okay. So for some reason the LED is not turning on. But let's say the LED is 9. It's been 9, right?
Yes.
Yeah, okay. So, pin 9.
Should we try a different LED?
Let me see this. This is always. I think it was the other way around. Because the larger one goes with the positive or the. There you go. Try spinning it now. Yeah. So it's kind of unstable because you need, maybe when you move it, but it's working. Yeah, great. Make sure that always when you work with the LED, like the larger leg goes with the digital pin. The resistor, yeah. Okay, guys. So we're gonna start with the last project, with the final project for this workshop. And so I'm going to upload the code for you guys if you want to use it later. But let's start first with the... So we're going to build an AI tic-tac-toe game. We're going to be using something called a minimax algorithm. It's widely used in game theory. So the AI engine is going to be using the minimax algorithm that I'm going to explain later on. But the main... or the most important component that we're going to be using is an infrared receiver module. You can see it in your kits when you, like, in the other side of the, you have like a list of the components. So it should match. You can start finding that component. So that's basically an infrared sensor that we're going to be using. That's, for example, what TV has in order to read the infrared light from the remote controllers. What it does is reading infrared signals, which of course is not noticeable by human eye. And what this module is going to be doing in the Arduino, so we're going to be using a library that you're going to see now. So what a library is open source code that other people provided for us, because it's not only using analog reads or digital reads, it's like doing a lot of conversions behind the scenes, and using libraries speeds up the development process a lot. So if you guys want to start, like, because we're going to need it for the project, so if you go, I'm going to show you how to do it exactly. So if you go here to Arduino IDE, you need to click here in this, like, the book icon, and then you should type the name of the library, which is IR remote. And make sure that when you go here, you found it, make sure that you don't install like the last version. You have to install the 2.6.0, which is this one, the 2.6.0. So anybody had a problem finding it? What happened? So go to the library manager, like click this icon, the books, on the left. The left bar, yeah. Did you guys find the library? Yep, okay. Remember, you need to install the 2.6.0 because if not, it's not going to be compatible with our program. 2.6.0, yeah. So also make sure that you start finding this little component. This is our infrared sensor. Make sure you also start looking the little remote controller, which is also called, let me see the name, is the remote control 1 PC. So, because it's in the same frequency for the infrared module that we're gonna using.
So what's the extension we have to download?
The IR remote. So that's the name. By Sheriff. Credits to Sheriff. Yeah, you have a question? Oh no. Oh no, I thought you had a question. So 2.6.0, exactly. So everybody got the library already?
Yeah.
Okay, so let's move on with the electronics part, which is gonna take like 10 minutes because, or maybe a little bit more, but if the quickest we do it, the better. So in this picture, I just only show the diagram for the infrared module. But again, we're gonna be doing or building a tic-tac-toe game. It's a 3x3 grid. So we're gonna be using 9 LEDs. If you don't have it, let me know because maybe you have like 8, 7 or something and I can give you more. But I didn't put the grid because I want to give you the design. It's up to you. So make sure that there is space in between the LEDs because remember that we need to use 220K ohms resistors. We need to use like a lot of cables. So it might be a little bit of a chaos, the circuit, but yeah, so each LED is gonna represent like a cell in the game. And then the way that we're gonna interact is not with buttons, it's gonna be wireless with the remote controller. So start doing that and then we jump to the code. Oh, guys, and make sure that this diagram is connected to pin 7, I think, but make sure you connect the Y pin here. I'm gonna show you with the laser. This Y pin is connected instead of 7, it's gonna be connected to 12 in the code. And then the LEDs, I forgot to put it here, but should be from 2 to 10. So instead of 7, it's 12. Sorry, what? The LEDs, yeah, like you have 9. So remember that the longer leg of the LED should go to the resistor and then to the pin. Have that in mind because that's going to be times 9 this time. Yep. Oh.
So we're confused on where to put the resistor so that all the lights are right above it.
So each LED will have its own resistors. You're going to be using 9 resistors as well. And I recommend like spacing
Spacing them, yeah.
in between.
So like, just for reference, so this is a long leg?
Yeah,
So
exactly.
like that?
Yeah,
Okay.
basically.
And we do that.
And what you can do is you just connect one ground here from the Arduino. And then, for example, for the, you can also, so yeah, wait, because, so instead of using like more cables, what you can use is use the resistor in the other pole. So the negative one, this was the right, the longer one?
Yeah, this is the long one.
Okay, so you can flip it. So now it's the resistor is connected to the negative thing, and then you just can, like this. So you save one wire for each LED.
Okay.
And then you just connect the digital pin to that one.
Like,
This leg, right? The positive one.
okay, so what do I connect to here?
What do you mean?
Like,
Sorry?
what do you mean by the digital pin?
So, no, like the same as before. So instead of just connecting to the resistor, now the positive is free. So you just put it here, for example.
So you're saying, like, for the next one, I put, let's say, this here,
Yeah.
and then I put the resistor on this side.
Same design, yeah.
Okay.
Then, for example, this, well, let's say you connected like one pin, and you just put it here or here, yeah, for each of them.
Okay.
Yeah.
Okay.
Because now the resistor is blocking the negative current. Yep.
How do you orient the 3x3 grid? So put the long legs.
So it's up to you as you think it's more. So make like consider that you're gonna be using 9 resistors.
Yeah.
So the same thing that I told them, you can use another instead because we always use the resistor to block the positive energy.
Yeah.
So now we could use the negative. So for example, let me show you an example and then you just copy it. So remember the larger one is for the positive. Let's put it like, for example, the first row is here. So give me one wire. So after you connect one ground to this row,
Yeah.
so you just, wait, which one was it? Okay, the last one, okay. So you just put it, you can use, then after you have the ground, for example, let's say this is a 220 ohm resistor, you just put it on the left. Wait, again, I forgot. Okay. So now you're going to be using the resistor to block the negative. So you just can do it like that. So you say one wire.
Oh, okay.
And then you just put the positive pin to the digital.
Oh, okay.
So you're saying one wire for each LED, which is better.
Okay, so just one wire for each row?
Exactly.
Okay.
So
then-
yeah, like column. You mean column?
Each column, and then I just put, oh, that's cool. Sensing something. So I just put,
Yeah, sensing probably someone else's infrared.
so here on the,
Does this even have a...
so I just do this, and then, or here rather.
like... No, so you need to put all the LEDs in different columns.
Oh, okay. Oh, okay. So different columns. So it'd be like here?
So yeah, I recommend, is it just like doing, having more space in between each
Okay.
LED. Yeah,
So like-
so you don't struggle with the circuit.
Yeah.
I know it's kind of,
Wait, positive was on the right side, right?
yeah, on the right side. So remember not to like, so when you put, for example, the second row, if you put it like here, make sure that you have space in between the rows, right? You don't want to use the same energy as these guys,
Yeah.
basically. Yeah. You guys need help? Yep. I got you. Okay, so, wow, you got that one? Great. So I'm going to do one, and then you just copy the design for the remaining 8 of them. So the larger one is for the positive.
Okay.
The same way with the shorter one is the negative.
Oh, okay.
So let's say we want to build, like, we want to do like one row here and one row here and the third row here.
Okay.
Okay, so let's do the first row, let's say here, right? Always put the right, like the positive or the larger one in the right part, right? In the right, yeah. Well, actually, let's put it here. Okay, so you want to connect, so let's say we have this one. You connect then you connect the ground to here. See, this is sensing something. Someone is clicking the, so is this working?
No, I think it's like just based on the motion. Like if you move it, it starts blinking. I don't know.
Is it the actual
Is it
thing
from
that you have to
the
use?
before?
I think it's fine, that module, right? Because it's not, I see it's not sensing.
It senses something if you move it.
If you move it,
Yeah.
maybe because the circuit is. So ground.
I think the remote, we didn't take the out.
Yeah, we didn't take it out. so
Oh,
it's
try it.
taking it out.
I mean, yeah.
Okay.
Oh, there you go.
Oh, great.
So that's working.
Okay.
But now we need the design of the game. So the right one, okay, so the right positive. So after you connect to the ground, right? So there you have the ground. And then, for example,
Wait, so for the ground, it's just leaving it to the.
no,
Wait.
not literally to the ground, like the ground here.
Oh,
like you
okay,
need to
okay,
connect
okay,
one
got
ground
it,
pin.
got
Yeah,
it.
so you feed the positive, the negative row.
Okay.
So now you have energy all throughout the row.
So one connecting from the negative
Yeah.
to the.
So now, what you can do, so now grab the resistors. So we need one for each of them. So we grab the 220. Where are they?
This one, I think.
Is it? Yeah. So I'm gonna grab one and then you, sorry, my bad.
So it's okay.
No, don't worry. So, for example, now we can use,
Okay.
so the resistor is bipolar. So it doesn't matter if you restrict the negative current or the positive.
Okay.
You can restrict both. So either, actually, not both. So remember the left one is our negative. So just to save one wire for each LED, you can just put here the resistor, right, feeding from the energy the negative thing, and then you put it here in the negative leg of the LED, which
Wait, it has to be in the same, or it's from a different?
no, it should be in the same column. Yeah, I mean from here it could be anywhere like in the
Okay.
negative,
Okay.
but here it should be in the same column in this part.
Okay.
So now you have the negative connected, and then you just connect the pins that we're gonna be using from 2 to 10 inclusive. So 2 is gonna be the first, like top, like upper left, let's say,
Okay.
like the first row, first column.
Okay.
So here, yeah, you have the, I don't know, for example, this.
Yeah.
So here it would
Okay.
be. So literally here, 1.
Okay.
Okay. So it should be 1 is gonna be mapping to pin number 2 in this thing. So then, for example, let's say this is our 1, the first cell. So what you're gonna be doing is grab one thing,
Okay.
then you connect it to 2
So it's going to be starting from 2 and
and
going
to
up
10. Yeah, so 3 is gonna be 2, 4 is gonna be,
in this order. Okay.
yeah. And then you fit the right leg. And there you have your first
First
cell.
cell. Okay. Got it.
Then you need to copy the same design, so make sure that it matches the real life game, right?
Okay.
Because then when we run the code, it's gonna be like any cell, yeah.
Thank you.
Okay, you're welcome.
I don't have time. I thought it was
Oh, okay.
How's it going here?
I am trying to wire it up for the tic-tac-toe.
Yeah,
Let's see.
yeah, so,
So it's just, this is the ground pin right here?
yeah.
Okay. Pin 7 on the right, 5 volt on the left. Why is it like? It's 3 holes of space between. I mixed it up, I think. This is supposed to go, oh no, never mind. It's just the wires are weird.
I suggest starting also with the grid, because that's gonna take, like with the LED grid.
The LED grid?
Yeah,
Okay.
3 times 3.
So 9.
So make sure you use 9 resistors. And the design you could use, for example, so in the other workshops we use the resistor to restrict the positive current,
Yeah.
always. But the resistor is bipolar. You could also restrict the negative.
Yeah.
So what I suggest is connecting 1 to the ground, like first feeding the row, the negative row,
Yeah.
right, from the Arduino, and then use each resistor from the, let's do 1, let's, for example.
I don't know if I have time to actually construct it in time before 6.
Don't worry. Try it, at least.
Okay.
So we got, for example, remember the shorter leg is the negative?
Yep.
So this one we're gonna be using for the positive. So we just wanna use the resistor. You can save 1 wire by doing just this, literally.
Okay.
Literally. So then you just connect this one to the digital to feed the positive.
Got it.
Got it? And then make sure you map, for example, let's grab this. So you can check it's working because it's working. It looks like something you might be messed up, but
No, there's no code running it.
no, but it should read. Oh, there you go. Never mind. So it's electronically like working.
So this from the positive pole should. Let me check the.
Yeah. So
The digital pin, yeah.
yeah. Yeah, that's go to the digital pin. So
Okay,
let's say we had, this is a tic-tac-toe, right? This is the grid. So this is the first cell.
Yeah.
So
So I can put it like digital pin 6.
make sure, because we're gonna be using pins from 2 to 10,
2 to 10.
being 2, the first cell.
Okay.
So make sure it maps. So if you want to use this as the first one,
I'll play as the
make
middle
sure
one.
it's pin 2. Or pin 3 if you want it to be like in the middle.
Okay. Well, pin 2 is the first one.
So it's So this is pin 2, this would be pin 3, pin 4, and that's it.
Yeah.
And be careful whenever you do the second row that it doesn't collide with these columns.
Okay.
It should be in different columns. You don't want to mess up with this energy.
Okay.
Yeah, remember that. How is it going here? Oosh. So, actually, have you ever played tic-tac-toe before? Just in case. Okay, so, because it should be like rows, right? Like 3, 3, and 3. 3 times 3.
So we have to put these 3 like above?
Unless you want to leave it like this and you know that these are different rows.
Okay.
Maybe. So for simplicity. So
Okay.
you can leave it like this and just connect from 2 to 10.
Okay.
Make sense? With the remaining leg.
So it's better for us to just like stack it up instead?
Yep.
Okay. So
What do you mean, suck it up?
Like basically go over it?
No. I mean, because of time, I think it's better if you leave it like this and you like you assume this is a different row, right? This is a second row, and this is the third row.
Right.
So just connect from pins to 2 to 10. So 2, 3, 4, 5, and then exactly you have the positive leg. You just put it there, literally. One pin here, one cable here, the other there, and there. The same.
Okay.
A link code easy and medium for hackerrank. So I don't know. It's not going to be that problem. I just don't know why you did it in Python. It's silly as fuck.
Yeah.
And he was like, oh, I didn't know any of the built-in functions.
Let me see because. Hold me one sec, because he asked me first.
How do we go into? I heard you say that it shouldn't be in the same column, so it shouldn't be like this.
So there it could be because it's in the opposite side. But if you do it in the same.
Oh, in the same thing, it shouldn't be here. It should
It shouldn't.
be somewhere else.
Exactly.
Okay, got it.
Never in the same column. Yeah. Close.
Oriented like this.
It looks good.
So like this, right?
Yeah.
Okay. And the wiring. So I put a resistor here, right? And do I put a resistor here, or do I leave it like this?
So wait. So wait, here you have a problem because you just need to put it like in between, right? So because in the same column, it's gonna be fed with the same energy.
Oh wait. So.
You need to just try to not to collide with the.
So, like instead of doing it horizontally, I'll do it this way.
No. Maybe you can do it like it's not gonna be like perfectly aligned. But what you could do is, for example, putting it instead of here, just put it, here in different columns. You know what I mean? Oh shit. Okay, something like that.
Yeah, like this, and then kind of like maybe a diagonal or something like that.
Yeah. Okay. No. Yeah.
And then.
I mean, it's up to you how you want to do it, but.
Kind of like a little diagonal or something like that, maybe? I don't know.
So you just need to like make sure it's not the same column. You don't need to do it diagonal.
Okay.
Can I have the IR in this orientation?
So it's constantly reading infrared things.
Oh.
That's weird. Maybe it's the circuit is maybe a little bit messed up.
I have the circuit in 7, and then I have the red in A5 and the black in GND.
GND, okay.
But I can have it like the circuit like this, like with it facing the back of the board.
No, it's fine. I'm just seeing if so 5 volt. So it's the same, right? Oh, maybe
Something in the code.
No, code is, no. That code actually is no longer useful. But maybe, so the 5 volt, you got the 5 volt in the middle, you got the Y for the pin. So Y is the pin. Well, let me see. Okay, so I see the problem. So you need to invert the blue ones, the blue with the red one. Sorry, the blue one with the black one.
Oh, okay. So put them in the on the board, right?
No, like just switch them.
Okay. Like this?
Yeah.
What's the remote control one PC?
The little remote controller. So you can check actually if it's connected, because you don't need code for this, like just to see if it's reading. So if you click any button, it should like get red, blink.
You just point at it like this, right?
Well, I'll actually need to remove this. Try now. There you go.
Trying to. It's a little.
That looks good, man.
Is it practical? That's the question.
It's not.
It's not practical.
Oh, so you're doing 3 lines for every...
Yeah, but I'm not sure.
For simplicity, if you want, you can just do it in a line and you assume there are different rows.
Okay.
If that makes sense, because we are running out of time, but... Oh, wait. We're running out of time, but... Because the circuit is taking a while.
Nope. I tinkered with it, like, tried to last semester, but I couldn't figure out how to work the IDE.
Oh, the Arduino?
Yeah.
Arduino has like built-in tutorials.
You do?
Yeah. There's like it's like somewhere. I think it's called examples, basics, analog read serial, bare minimum.
Yeah.
Link has tutorials. Well, they're not exactly tutorials, but they
Like pre-built code, yeah.
Yeah, show you real code, and it shows you what the code does, and you can use the code and stuff.
How's it going here? Oh, you're with the code? So I put the to-dos. There's a lot of stuff, which is the the algorithm, like the AI thing. You don't need to touch. There you go. So. It's going
My
good.
solution for the middle row is just to put it on the other side.
Yeah, I know, the circuit is tedious.
Yeah.
Yeah, I know.
You said put it on the negative pole and then connect it to the negative
Mm,
to do the shortcut, because that's what I saw you do.
yeah, with the shortcut, yeah.
I mean, look, at this point, it is 6 o'clock. I'm gonna say I'm done. Look, this is enough. I have to pack this up.
Okay, so if you want, you can check the code that I uploaded
Yeah, I will.
in the final project.
Please tell me it's complete.
It's complete.
Okay, let me reload.
You have two, both of them. So if you want to implement it, you can use the
I could, but I don't have an Arduino project of my own.
project and resolved.
I'll just look at the result one. Okay, cool.
So there you have all the AI algorithms that you don't need to touch.
Yeah.
The Minimax.
Okay. Yeah. Cool. I'll take a nice look at it.
There you have a lot of code for you.
Yeah. Yeah, I'm bored. I might as well look at code. Alright, let me download it. How do I download this?
I really don't know why it doesn't allow to download it. Like,
I guess I'll just. Wait, can I? Okay, good. I can't. Oh.
I think it's better if you just do Control A.
Oh, yeah. Let's see if that works.
Yeah, and Control C, and then you paste it somewhere.
I always forget. Control A.
But
is the thing.
you're gonna have that file, like it's not gonna disappear, the link.
Yeah. Cool. Perfect. I'm saving it.
The circuit is tedious, I know.
It's a little.
A little too much.
It's a little complicated, but the kit's only like what, $30 on them? Yeah, it's only $30. I'll get one and try and figure it out.
So guys, I also uploaded like both the code that is for you to complete and the one that is fully working. So if you finish it or if you want to check how it works, so you also have the code there if you want to see, like project 2 result, basically.
Is it possible just to do all like the lines on like a single line circuit?
A single line? I don't know. Yeah.
Is this like?
It's not gonna work.
No.
I suggest like putting all the LEDs in line, like the same way they did.
That makes sense.
So that's a shortcut, basically. But you need to assume there are different rows. Oh, you gave up.
No, I'm gonna put them in. I'm gonna put them in rows.
In rows? Okay.
And I know because I'm gonna color code each row. I'm gonna color code them. Yellow is top row.
But she needs to be careful with her.
Excited for the 26th.
Yeah.
So we copy pasted the code that you uploaded,
Yeah.
and we're like unsure if we're supposed to like. Is there something that we like press on to make it work?
So yeah, I see first is missing like all the digital pins for the LEDs. Oh, sorry.
So what are the digital pins?
Digital, like from 2 to 10. So this should be 2 all the way to 10. Like here on the positive. Remember that how we turn on the LED?
I'm not sure what you mean.
Like, for example, let's say we want to connect. We want to connect, for example, 2, and then there.
And that's for each one?
Exactly. So 2 to the first cell, 3 to the second cell.
Okay.
Yeah. And then then you should use so to manipulate the game, you need to use the remote controller. Is it here, by the way? Yeah. So actually, you can test if this is working without code. So when you click a button pointing towards it, it should like turn on. Try it if you want. See if. You're close.
I'm close, finally?
You're close. Now that you need the resistors, right?
Yeah. And then these go on the right prong, right?
Wait. That's on the right pole, yeah.
On the right pole, the long pole. Right?
The long pole, yeah.
Okay, there we go.
Perfect. Make sure all of them are the same.
Yeah, let me check. Long pole, long, long. And then I have to get 9 resistors.
Exactly.
Then
9 resistors,
these are
220.
resistors, right?
Those are 220?
This one has an orange stripe. The orange stripe is a
I
220.
don't remember by heart, but
It should say 220 on the orange stripe. That's what.
no, that's a 10K, 100K.
100K.
Look at the.
Oh.
You are blocking a Tesla.
Everything, literally. I'm blocking everything.
So look for the 220 somewhere.
I can put the red wires in 0, right?
No.
Yeah, 220 here.
But do it from 2 because that's where the code maps to.
2? Okay.
Yeah, from 2 to 10.
2 to 10? Okay.
So 2 is going to be like mapping to cell 1, 3, cell 2, 4,
And then
3,
it's,
and so on and so forth.
Resistor from the negative prong to the ground?
Exactly.
Okay, perfect. Got it.
Yeah. So it's a shortcut. You don't need a wire for the negative part.
Something's working, but I don't know what is
Oh.
working.
You don't know
Because-
what?
Because, okay, so the number that we click is corresponding to this, right?
Yeah.
So if I clicked 6, I got 5. And then the AI selected 2. I don't know which lighted up because this is supposed to be 2.
So this is connected to pin 2.
Yeah.
Okay, which one is this? Which pin?
2, 3, 4. That should be 4.
Pin 4?
Yeah. This one is this. Yeah. Yeah, it's 4.
4?
But
So 4 is mapping to 3, right?
4 is not.
Or 5? 4 is mapping to 5. So when you click, so what button did you click?
I clicked 6.
6, and it's mapping 5.
And it's mapping 4.
4? So,
Some, I don't know what's done, but okay, so
when you click, so what you can do, for example, excuse me, thank you. Let's go all the way up. So where I define the,
numbering.
yeah, the cells. So here, so this is the first cell, this is, so
Right.
if you want to simulate or adjust whatever you have in the circuit, so try like clicking 1, which one turns on?
Oh, okay. 1, like actual 1 or like some random number.
Yeah, the thing is, that's AI call, yeah.
Okay, so the green is AI. Oh, wait, not green in the sense like the one
Yeah,
that
no,
lights
no.
up is AI.
Yeah, the one that blinks before showing like full is AI.
Okay,
So let's try another one to see if, the thing is, probably yours didn't turn on, but for a circuit problem, maybe. And then hit another one, I think it should finish in this last one, 9. And then it finished.
AI wins.
AI wins, but we don't know what happened.
Yeah, that's the thing. It happened twice already. I don't know which one's mine and then which one's AI.
No, yeah. Because you might adjust it. So this is like the base code. You can customize it.
Okay, yeah.
But then, for example, because in the activity I try to like, when you update there is a function called update LEDs. So if you want to differentiate between AI and you, maybe you can just, for example, you is always turned on and AI is always blinking.
Oh, yeah.
For example.
Okay. Yeah, and also how can we test which one's which? Like, let's say if I press on 2 should light up, 3 should light up.
Yeah, so
Or 4.
if you have everything, all the circuit is fine. If you click 1, so it's going to map to cell 0. That's expected. It's 1 less than because it's an index.
Right.
Because this is using an array
Yeah.
behind the scenes, right?
Right.
So button number 1 is cell 0, and whatever lights up, then that's your first pin that you should put here. Oh, it's touchless. It's touchless. My bad. So, for example, let's say you click 1, and then the LED that is connected to, let's say, pin 4,
pin 4.
then you put 4 in the first place instead of 2.
Okay.
So then you just can start mapping
Okay, so that's
to whatever happens in your circuit.
Okay.
Yeah.
And also, like, quick question, because I don't know if I'm doing it right.
Yeah.
Whenever, I want to run the code again, you just click this, right?
Upload, yeah. Whenever you make an update or something, you just upload it.
So how do you, this is run?
That's the serial monitor. So that's to see the output, right? To debug.
Okay. So now that, there's like one game is completed and I want to start again.
Yeah, so that was also to like implement the reset part.
Yeah.
But for this backbone or the structure, like the one that I uploaded, it's just like you need to unplug it in again.
Oh.
But it's good if you come up with the code to reset the state.
Okay.
So you need to reset the cells, the LEDs, everything. Yeah.
I think so. Okay, I'll try again. And then
Yeah, and if you want, you can. Yeah, no, I mean, how many LEDs do you have there? 1, 2, 3, 4.
There's 9.
There's 9? Oh, yeah.
I tried to like color code it so that each row is different.
Yeah, it's good. So, you're sure that all of them work?
Yeah, but I don't know why. Oh, in the sense like the LED.
They turn on? Yeah.
I'm not sure.
Mm.
But like the connecting wise, I've connected everything correctly.
Oh, sorry. Yeah. Okay. So let's try, for example, let's do an example like unplug it in again.
I mean, I could.
Yeah, you can just upload it, yeah, but it's better.
Because I just did that.
So, okay, so click 1.
Okay.
It takes a while because the first move,
When I click 1,
it sells to 0.
yeah.
It's expected, that's expected.
Oh, that's it.
Because that's it points to the index 0 in the array.
But then it stops there, so I have to like.
No,
start it
so
again.
so now it's AI thinking. The first movement always takes a while
Oh, okay.
because it's a recursive algorithm and it checks like all potential outcomes. And then based on the final outcome, it makes its move. But the first one, as it has like the most of the possible
Yeah,
outcomes,
right.
it's more like the time complexity is higher, yeah. There you go. So, okay, nice. So it turned on. So yours is fine.
Yeah.
So
2,
1
3.
is 4.
Wait, 1,
So
2, 3.
exactly. Yeah, so AI did 4.
Wait, that's not 4 though.
That's 5,
Yeah.
which is fine. Remember that the index is cell minus 1. So that's good.
Oh, okay, that's good.
So the pins are working fine.
Oh, okay.
So now, like, try 2. No, that one is bad, you see?
Yeah.
So it blocked you, actually.
Right.
You see? Because
Okay.
because you had this one and now you had that one.
So maybe those two are swapped.
Exactly, you can just swap it in the array. So for 3 and 4, you can swap it in the code. No, I mean, it's better if you just swipe it, yeah.
So like here?
Yeah, there you put 4.
4 and 3.
Yeah, exactly. So you're just changing the order of the pins. So now it's how you start.
Okay, it's basically off trial and error.
It's trial and error, yeah.
And then you get to know what.
I mean, it shouldn't be, but for some reason it is.
I don't know, like that's the weird thing because it's connected in the correct order.
Is it gonna? Yeah, well, it might be a problem on my end actually, but you can just adjust it. So make it 1.
That didn't light up. Okay.
That didn't light up, yeah. That's weird.
I did notice that like the first move that I make doesn't light up. It lights up after.
After the AI makes a call, yeah, might be some bug,
yeah.
which you might also adjust if you want. So you have a lot of like bugs, but yeah. Oh yeah, sorry.
So like this?
Okay. Yeah. So
And then
you're already playing? No.
No.
So upload the code, like the final code,
Okay.
the one that I uploaded, which has the AI built in. Hardware build. No, that's actually the first cohort.
Oh wait, yeah.
That one, build your own mini robot. So it's.
The darker red is supposed is
So yeah, that one resolved.
on the resistor.
What? What happened?
No, the resistor. It's supposed to. The darker stripe is supposed to be next to the bulb, right?
The darker stripe.
Yeah.
No, it's bipolar, so it doesn't matter.
Oh, okay.
Yes. Oh, thank you. Oh, this is cute.
Yeah, remember it has a little film on it. So it's not
Is that for
actually those
everyone?
colors.
Oh.
What's yours?
Gabriel.
I don't think you.
The QR code, right? Yeah. I got that.
But let me see if
No, I think he didn't. I think he, because that's, yeah. No, no, no.
I got it. I'll fill out right now.
You had a question? Oh, yeah. Let's see. So,
It just turned on. We're not sure how it turned on, but if we restart it, it just is completely off. We're not sure how it turned on.
are you sure you're using the correct resistor before? Like
Yeah,
first?
this is 220.
It's a 220. I don't know why it's that low. Like the brightness is messed up. It is so microscopic. Let's see. So, the leg on the left is a positive one, right? Like from your side?
Yeah.
Okay.
This is the short leg.
The right one? Okay. Really? Is it 220?
This is the last one we used.
That's so weird. And the other LEDs turn on?
Like, we have the white one turned on,
Yeah.
but we're not sure how it turned on. And we just played with it, and we saw that it turned on. But the rest of them, we're not sure. And the blue one looks like it's on.
So, okay, so let's upload it again to see if, I want to see how it behaves. Put the serial monitor, because the serial monitor gives you like the game messages. There you go. Okay, so now touch any cell, like first cell, let's say, or second, yeah. Two.
Then we see this turn on. This right here.
So,
This turns on.
yeah.
Click any button here. But that's all that I see.
Wait, because the first move takes its time because the AI is using like a recursive algorithm, and when it has like, when it's at the beginning, it analyzes like all potential outcomes. So the first move it takes a while. So, like 20, 30 seconds. Use the, wait, go below. Is it like, no. This is weird. It's not. It's actually not reading the. Why?
Does it matter, like the order maybe?
The order. Let's go to the code. 1 sec. Go to the void loop.
The white note?
Yeah. Not that one.
Is this one?
Yeah, okay, so here we have, no, that's the setup. Go to the loop. Okay, here you're saying, okay, it's if it receives something, decode it. So what this thing reads is like digital values, like some number encoded values, hex codes they are called, and then sorry.
We usually end at 6.
Yeah. Sorry, yeah. We're gonna back up.
No, not at all.
Let's see.
Yeah.
Yeah. Oh, we ran out of time. Yeah. No.
So sorry. Usually we do end at 6, but it went a bit over because we have the final part.